Good afternoon. Welcome to our class today. Today we are going to learn on how to construct a regular polygon. And I'll have a question to help us do our construction and see how we construct different polygons. I'm going to do one method, that is construction of a polygon when you are given the diameter of a circle. Or in other words, you might as well be given the radius and you're supposed to bring up the polygon. Now in my question, the question reads that construct a regular heptagon within a circle of diameter 60 millimeters. The corners of the heptagon must lie on the circumference of the circle. So I'd like us to at least understand the question. The polygon that we're constructing is a 7-sided because we are told that it is an heptagon. So an heptagon has 7 equal sides. And we have the length of diameter, that is, we know our diameter simply from 2 points of a circle within x and y, we have 60 millimeters. Now, let's go and construct and see how we are going to have that heptagon. So I'll have a line. Begin by having a straight line. If you have your T-square, you can use that. Then our diameter is 60 millimeters, and that tells us to get a circle of 60 millimeters, we'll simply have the radius of 30 millimeters, diameter divided by 2. So a radius of 30 millimeters. To construct my circle, that is it. So this is the diameter, x, let me call it x and y, that is the diameter. So if you happen to measure this length from point x to point y, within that circumference we will get the diameter of 60. Now procedure number 2 is that we are going to divide our length xy of 60 millimeters to equal number of the sides of the polygon which we are required to draw. That is, for our case, we're going to divide x, y into 7 equal portions. Now, using the knowledge on division of a line, so first of all, so in division of a line, you draw a line from point x of any angle. So that is my line, as you have seen. Now we're going to divide this line to 7 equal portions. So I've simply divided my line. This is from point 1, 2, 3, 4, 5, 6, 7. I hope you can see those divisions. Now we proceed. Now join point 7 to y. 7 to y. So the last division to point y. That is it. Now we're going to do the same. Ensure that we get all the equal portions. That is it. Now we're going to sweep that line as we divide point x and y, Ensure it's really lying on that last division. So that's 1. Make sure you begin from the furthest point. So I've divided my line xy to 7 equal portions. So you can count 1, 2, 3, 4, 5, 6, and 7. Now, next procedure is that I'm going to take my pair of compass. Please observe this carefully. Take a pair of compass, put it at point x, take it all the way to point y. That is simply that diameter of the circle. And we're going to make an arc here. Do the same at point y. Please observe where my x axes are intersecting, or you can as well make this as whole like that. Good. Now, point O is my point of intersection of the two arcs. Point of intersection of the two arcs. Now, I'm going to name the divisions. Please, this is very important. 1, 2, 3, 4, 5, 6, and 0.7. Now, next thing we're going to do is that we're going to project a line from point O, which was the point of intersection of two axes. So point O through point 2, and make sure it proceeds to touch this circumference at point M. I'm going to show us that. So from point O, make sure it's passing through point 2. Is this. Through point 2 and to touch the circumference of the circle. Let me call this point M. Now, XM, we're going to draw a line from XM that will give us the length of one side of that polygon. X and M is one side length of the polygon. I'm going to do that with my HB. Please make us see. So X to point M, XM. You can be able to see that very well. That is the length of one side of the polygon. Now we're going to pick this length, XM, and divide it all through that circumference of that circle. Remember that our question was telling us that the corners of the heptagon must lie along the circumference of the circle. Now I've already made the arcs along the circumference. Remember, each and every arc here is equal to the length XM, which we said that it is the length of one side of our heptagon. Now we're going to join each and every one here to give us the heptagon which we were constructing. So I've joined the arcs all along, and this is the required heptagon. It's the heptagon we were constructing. Now our length XY is simply the diameter, which we were given as 60. We had to construct a circle with the radius of 30 and divided that circle to the equal number of portions that our heptagon would require. In our case it was 7, that's why we divided it to 7 equal portions. We made the arcs from point X and Y to meet at O, projected through point 2 to touch the circumference at point M. So XM gave us the length of one side of our heptagon, and using that length of one side, we divided it along the circumference. This is our required heptagon. Thank you for listening. Please subscribe, and let's meet again in our next class.